Hello, my name is Mike Driscoll, and today I want to talk about data science packages in Python. There are a ton of them. So let's get started. Some super popular scientific Python packages are pandas, scipy, and numpy. These have been around for quite a while. You probably know of pandas with Python as kind of a data analysis library. It is popular for doing all kinds of data analysis on big data and small data. People use it to read CSV and Excel files to get the data in, and it basically turns it into a data frame. And lets you do lots of different cool data analysis, things that I know nothing about really, because I don't do data analysis on a day-to-day basis. There's lots of books about the pandas library, and it's definitely one that you should check out. Let's see, we also have scipy, which I believe stands for Scientific Python. Let's take a look. Scipy has been around a long time as well. It has fundamental algorithms for optimization, integration, interpolation, and lots of other things like diffeq, algebra, statistics, and etc. So if you need to do advanced mathematics, scipy is your friend. NumPy is another one, and that's really popular, and I think pandas is kind of built on top of NumPy, or at least is closely related, because you use NumPy and pandas together often. So NumPy is kind of the fundamental package for scientific computing with Python. I believe the people who make NumPy also make scipy. They're kind of close together. And I think NumPy used to be called numeric a long time ago. Anyway, all three of these libraries, I believe, are based around a C code underneath the covers. So they're all very fast, and they're all super helpful for doing mathematical things. NumPy is good for random number generation, linear algebra, Fourier transforms, and more. So definitely check these out if you got to do that advanced math in Python. Data visualization. There are a ton of packages for data visualization in Python. This is just a small sampling of some of them. Matplotlib has been around a super long time and integrates well with some of those other packages I just mentioned, like pandas and scipy. In fact, I think you can get them all together if you download Anaconda, which is a scientific Python distribution in many ways. Seaborn is basically built on top of Matplotlib and makes it look a little bit nicer. Then you've got Plotly, which is kind of an online data visualization package. Bokeh, Altair, HoloViews. And if you click on this link that I've provided, pyviz.org has a whole bunch of different packages and kind of what their core is. So you've got Matplotlib, Plotly, Bokeh, and then you have some high-level shared APIs. Libraries that share the pandas' plot API, which is built upon core Python or JS libraries. So then you just kind of look over here and see what's going on. Pandas uses matplot, Cufflinks uses Plotly, hvplot uses Bokeh. Pandas Bokeh also uses Bokeh, so you can use pandas for matplotlib for the backend graphing for pandas, or you could use Bokeh if you have this extra plugin. And then of course we have all these other ones: Seaborn, Altair. What does this V stand for? I should know. Vega. Yes, I keep forgetting that one. Anyway, there's a lot of really interesting ones you can check out, and this thing just keeps going on and on and on, and gives you lots of great ideas about how you could visualize data in Python with extra packages installed. All right, computer vision. There's actually more than just these three libraries, but these three are probably the most popular. So Python and OpenCV have been together for quite a while now, and I think OpenCV is probably the most popular package for doing computer vision with Python. Note that when you want to install it, it's OpenCV-Python, not Python-OpenCV. I'm always getting that mixed up, so I just wanted to point that out. If you want to learn a lot about computer vision in Python, you definitely want to check out the PyImage search website. Adrian, who runs this website, has a ton of free content and a lot of awesome paid content, and he will teach you how to do all kinds of great things or you could buy his books and learn that way too, or his courses. And he's recently started hiring other great teachers for his site. So definitely check this place out. It has tons of great free content that'll help you learn how to do computer vision well. And it doesn't just cover OpenCV. He also covers Scikit-image and mahotas too. I don't know how to pronounce this one. I'm just guessing. I think it's mahotas. I kind of like Scikit-image. Let's go take a quick look at that. So this one I think has better examples, like right off the bat, than OpenCV does. If you go to the OpenCV website, they've been working hard on it and they've been improving it. But I mean, it's really hard to beat something that has like 5 lines of code and you're already learning how to use a package. And I just think that Scikit-image does a really good job of giving you short code snippets that actually do something amazing. Okay, and mahotas. Let's look that one up quick too. Mahotas. Alright, this one I think is a fairly new library compared to the other two. But it has a lot of things built into it. And, you know, I haven't done a lot of computer vision, so I don't know what all these words mean here. You know, watershed, thresholding, I kind of know that one. Morphological processing. So anyway, I'd check it out, see if it's if it fits your brain better than OpenCV. It might be a good option for you to check out. Definitely worth a try anyway. All right, machine learning. There are a ton of packages for these too. These are not the only ones you could use, for example, but these are good places. This is a good place to start. PyTorch and Keras are both good for machine learning or deep learning. You know, I don't really know exactly what Theano is in Python, so we should check that out. But I know a lot of people recommend it when it comes to doing machine learning with Python. Let's see, mathematical expressions, multidimensional arrays. Okay, so this one kind of hooks up with NumPy. I think you might use it in like a pipeline with some of the other tools. So I might even have this one categorized wrong. Tensorflow, though, I know it has to do with machine learning. And Scikit-learn is kind of like Scikit-image, but it's for the machine learning side, whereas Scikit-image is for computer vision. PyTorch has been growing a lot in popularity. There's been a lot of good books on it coming out lately, and it just looks really interesting. It's something that I'd like to learn at some point with it, but you know, I always get hung up on, do I need to go take a bunch of classes to actually understand this code? And, you know, I probably do need to do something because I really don't understand, you know, the basics of even how to get started with PyTorch. But, you know, if you're already learning machine learning and you want to jump into Python, I think PyTorch and Keras are probably good places to start, and then add in some Scikit-learn and whatever else you need to learn. All right. There are a ton of other scientific packages that I'm not even going to cover in this tutorial, but I just want to give you guys some ideas of where to start your journey and, you know, see how amazing Python is and see all the wonderful packages you could use to get started doing machine learning and computer vision with Python. Anyway, thank you so much for watching, and I hope see you all next time.